Hello, today we're talking about the distributive property. You've already written down a definition in your notes, but today we're actually going to look at what it means and how to actually do it. With the distributive property, you are distributing something as you separate or break it into parts. So breaking it into parts. Think about distributing, the root word distribute. Distribute means to pass out. The distributive property makes numbers easier to work with. The distributive property lets you multiply a sum by multiplying each addend separately and then putting the products back together. The distributive property helps with mental math. So these are all reasons why, besides I said so, why you need to know the distributive property. So make sure you write down these notes in your notebook and pause if you need to. So there are two methods in finding the distributive property, so we're going to look at it right now for one. You can find the total area of two rectangles by two methods. Method one, find the area of each rectangle, then find the sum of the areas. So this rectangle is 4 by 3. So 4 by 3 is 12. And then 4 by 5 is 20. So this looks like 4 by 3 plus 4 by 5. And we've written it this way because we have rectangle 1 and we're adding it to rectangle 2 because we want to find the total sum of both rectangles. And using order of operations, 4 times 3 is 12, 4 times 5 is 20, and then we add it together to get 32 whatever square units we're using for this particular problem. Next problem, method 2. Combine the two rectangles into one large rectangle and then find its length, and then find its width, and then find its total area. So this time we are, our height or our length is 4 and our width is 8. So this time it looks like this. 4, let me move my cursor, I'm sorry. So this time we have 4, and then we're multiplying it times these two individual widths. And when we do that, you can see that we have 3 and 5. So we end up distributing the 4 to the 3 and then the 4 to the 5. And that's how we can find the area, by putting it all together. So that looks like the same. So that looks like 8, and then 4 times 8 is 32. So let's look at the example, putting it all together. So the first one we had 3 times 4 and 5 times 4, which looked like, which was the first picture. The second picture was the 3 plus 5 times the 4. So when we have that, that was the first one. And then our second example was the, whoops, that's not 3 times 5, it's 3 plus 5, times 4. These two scenarios are equivalent expressions because this is simply distributing the 4 to both rectangles. And that's why it's called the distributive property, because you're distributing the 4 to the 3 and you're distributing the 4 to the 5. And you can see that right here. So once again, and then 12 times 20 is 32. So it is a true statement. They're both equal to 32. So this equation is an example of the distributive property of basically taking the 4 and multiplying it, distributing it to both parts of the problem. So let's look at another example. To multiply a sum or difference, to multiply each number within the parentheses by the number outside of the parentheses. This is what we're going to be dealing with now. So we have our first example. We have A, right so you can see it bigger, and B plus C. So what this is doing, because right now you can't distribute this, can you? Right, because you don't know what B plus C is, or variables. But what that looks like is A times the B, which is AB, and we have A times the C, which is AC. And we're adding them together because this operation says to add them. If it said subtract, we would subtract, but it says to add it. So we're adding them together. And then that's our final answer for this problem until we're able to, get more information about what the letters represent. Another example is 2 times 3 plus 5. And what this looks like is we're saying 2 times 3 and 2 times 5. And you're going to get the same thing as if you did the parentheses first, like we've been talking about the order of operations. But it's going to get to the same value. And it looks the same as we could put the A on the other side, and we could put the 2 on the other side. It does not matter which side the number is on. All right? And one last one. So if we have the problem 4, this is another way of how to use the distributive property. If we have 4 times 53, and I said to do this in your head or do it without doing a lot of calculations, that's hard for a lot of people. But if you broke the problem up into smaller pieces and then put it back together, you'd be able to. So if I said if I broke 53 up into 50 and 3, then I can multiply the 4. So instead of saying 4 times 53, I can say 4 times 50 plus 3, because 50 plus 3 is the same value as 53. And that's what this looks like. We multiply 4 times 50, we multiply 4 times 3, and that's something we can do in our head. 4 times 50 is 200, 4 times 3 is 12, 200 plus 12 is 212. So that's a way you can use distributive property to help you work on some mental math problems or real life problems.